Okay, so continuing. So from kanina, so I have discussed already yung mga types of fittings that we have that we are going to be encounter that will produce a pressure duct. Now this is a converging duct. So it's the same sample of this one. Pabaliktad lang nga siya. Sudden contraction and sudden enlargement. So we have converging duct. So we have your equation. So this is from your Bernoulli's equation. Using the Bernoulli. So usually we have from Bernoulli's equation. So I will not derive it para we go directly to the equation. So from Bernoulli's equation, okay. So we have your change in pressure or your pressure drop from 0.1 to 0.2. So that is the change in pressures. So we have your equation of the density times the velocity 2. So that the 0.2 divided by 2 multiplied by your area. So this is area. It's the ratio of area from area 1 divided by your area 2. So square minus 1. Okay. So we have the equation now, which is yung P1, that is pressure at the point 1, and your P2 is the pressure at point 2. So let's define that one. So that will be, so take note the unit will be also in Pascal. So next we have the sudden enlargement pressure drop. Okay. So we have the corresponding, so you will notice this is converging or gradual increase in size, but this one is sudden, biglaan lang paglaki. Okay, so you will know, you will see the difference between this converging duct and you have your sudden enlargement. Now, so for the pressure drop between 0.1 and 0.2, we have your equation. You have your equation, the sudden enlargement. We have your equation of pressure drop that is equal to velocity 1 square divided by your density of your air divided by 2, then multiply it by 1 minus the ratio of area 1 and area 2, and this is in square. So this is common. We have the velocity and you have your density of air. So area 1, so ratio of this one and this one, then raised to square. So we have now the equation for your sudden enlargement of pressure drop. Next we have the sudden contraction of pressure drop. So the pressure loss between 0.1 and 2. So this is expressed in so we have P loss is equal to velocity 2 squared over 2 multiplied by 1 over C minus 1 over that is raised to square. So where the values of where the values of CC is from your Stoker. Okay, Stoker book. So table 6-3. So that is on page 112. Okay, so that is the value. So we have here the table of 6-3, that is when there's the Book of Stoker, page 112. Okay, so you will notice here, in order to get the value of your CC, so you need to get the ratio of area 1 and area 2. Okay, so starting from here, going here, so you will get, so you need to get the value. So take note, you need to get the value of decimal places. So sometimes kasi baka magkamali kayo in terms ng ratio ng nito. Baka usually if you go do ratio from higher to lower area, so usually you will get the whole number rather than decimal point. Now, so if you get the value of your CC, usually you have your corresponding, or you can directly go here. So usually this one is substituted in here if you're going to compute that by means of calculator. So if you get the value of 0.1, then you have 0.624. Then if you're going to substitute that one in the equation, so that is the same amount of 0.366. So it's better na you get this one, the ratio, then you can get the value of 0.366, then substitute it to the equation, then you have the P loss between the you have the pressure loss already. Okay. So I forgot to add yung there is something kulang kasi sa equation natin, since this is meter squared is second squared, so it does not simplify as the unit of Pascal. So we forgot to add yung density of air dito sa pag i-multiply natin with density of air. So we should multiply with the density of air here. So to clarify it again, rewriting the equation. So we have the density of air here. Okay. So if you're going to analyze the units, so we will have the pressure loss. So that will be meter squared, second squared. Then we have your kilogram to cubic meter. Okay. Then so kilogram, so if you're going to usually in Newton, kilogram, that is meter second squared. So ito na yung kilogram. Then this one will be multiplied by meter, and this is also subject to cubic meter. So this is already become Newton. Then we have here cancel out, so you have 2, so that is meter squared. So we have another unit of Pascal. So take note, pressure loss natin, that is in terms of Pascal, so or that is in metric, in corresponding to that one, that is in English, so that will be on pound force per square inch, or or it can be on pound force per square inch, or this is equal to your PSI, or sometimes that is pound force per cubic per square feet. So that is the ratio. Take note palagi. So that's why palagi kong nakasanayan ko na I always check with the units in order for me to also to counter check also the equation. So yun yung palagi sana itatak nyo sa isipan nyo, na the units are napaka importante in terms of checking yung value ng or not value but also the integrity ng equation ninyo, kung tama ba o mali. Kasi sometimes katulad yung kanina nangyari sa akin, I forgot to check, I forgot to add the density of air. So when I reread the units, so I was confused that the meter squared is second squared. It cannot be equal to Pascal. Okay, so there's something wrong with the equation. So that's why I checked the book, yun ang kulang. So I hope you will be siguro ma-adapt nyo rin yung ganyang tawag dito, kaugalian, para and later on when you're in practice you will be guided during your design process or during your work process, okay. So for turns and elbows, so we have these definitions of your duck. Okay, now we have yung tawag dito, chart. Okay, so ratio of inner to outer radius. Okay, we have doon sa baba, or that is WH4. WH, that is the ratio of your width. So this is for ratio of radius. Okay, ratio of radius to ratio of inner to outer radius. Iba ito. So let's say this one. So we have your curve WH. So that is the ratio of this one to this one. So we have the value of 1/4. So ang sinasabi niya dito na inner and outer radius. So we have here, if we going to draw your duck on the side view, usually this one. So magiging itsura niya is parang ganito, diba? Okay. So you have a curvature here. Forgive my drawing. Now you have from here, so we have your radius. So that is the inner, and we have another radius here. So we have your radius outer. Okay. So yung sinasabi niya, if you're going to draw your duck, so you can compute that one. So how much radius you're going to give. So you're going this one is the ratio of the inner, so that will be R1 divided by your RO outer. So yeah, makukuha naman yan by means of the dimension. So if you get the value of R1 or RO, so plot it here. So we have the decimal places R1 and R2, so it will be decimal places also. So if you get the value, for example, if you get 0.2 the ratio, then you have the ratio of your width and height of the duck. So kung let's say that is the value is 2, if the value is 0.2 and tumama yan dito, okay, so you have now the value kung yun ang tinamaan niya, kung 0.2 yan. So you have the value, sample lang ito, no? So if you have value that is 0.9, so ang mangyayari dyan, so you have your equation which is your P loss, sorry. So ang mangyayari dyan, which is your P loss divided by your velocity square times the density over 2. So this will be equal to the value which is yung kanilang 0.39. So kung yan yung naging value, so now you will be having the P loss, so that will be 0.39 times the velocity squared times the density divided by 2. So that is the pressure loss sa sa turns and elbows. So take note, the unit of also this one is also in terms in Pascal. Okay, so the unit here is Pascal, or let's say that is Newton per square meter. So this is velocity, so meter squared second squared. Okay, so already explained that one before. Now the pressure loss, so the pressure loss between 0.1 to 0.2 is expressed as your P loss. Okay, that is equal to your velocity 2 squared multiplied by the density of your air divided by 2, multiply that by 1 by 0.4, then multiply it by 1 minus your velocity 2 over velocity 1, so that is squared also. So that is from here going here. So if you will be, your ducting will be working, passing here, going here, so you have now the pressure loss added to the system. Now for the pressure loss, dito natin siya, lipat natin dito. So, continuation. Okay. So for the pressure loss to P loss, so P loss going to from point 1 to point 3, okay, is expressed as P loss, which is equal to your velocity 3 divided by 2, so this is raised to square, then times the density of your air, then multiply it by the geometric factor. So since paiba-iba yung take off ng sometimes that is 90 degrees, okay, so metered, okay, metered type of branches. Okay, so the geometric factor makukuha siya dito. So since given natin doon, we have your angle. So how much is yung angle na ito if you are given here? So for example, if the angle is 90 degrees, so usually if we have ducting, if that is 90 degrees, usually ganito ang magiging itsura. So straight duct, then branches na ganyan, usually you have so usually ganito magiging itsura if that is 90 degrees. Okay, so you have shoe duct, branch shoe, then ganyan, okay. So air passing here, air passing here, so you have the angle of 90 degrees. So if you have your angle of 90 degrees, then plotting it here, so the ratio of branch to upstream velocity na lang ang kailangan mo. So this is velocity of the upstream, which is your velocity of your, so upstream, which is the velocity of your V1, upstream ratio of branch, usually that is branch. So this will be in sa baba ng value, that will be V3 divided by your V1. So ito yung magiging value niya. So kung ilan yung magiging value niya, usually V3 is mataas palagi. So since it is maliit lang nun, maliit ang value, so pwede naman bumaba in decimal places. So that is the ratio of V3 and V1. So if you get the value of V3 and V1, so plot it in here. For example, if we got value of 0, ratio of, for example, sample natin, so B3 mabilis, so usually lagyan natin ng 9 meter per second divided by yung sa main duct mo, that is maybe around 5 meter per second. So ilan yung value niya? So I have the value of, so this is 1.8, okay. So 1.8, so somewhere in here. So here. So tansya na lang yan. Tansya na lang ito. Since, you're gonna plot that one. So, draw natin ng shapes. Okay. So, here, that is 90 degrees. Okay. So, dapat pula. Para makita. So, color it red. So, ayan. We have, okay. Then, dito sa kabila corresponding niya. So, you have the value of 0.8. So, your P-loss will become now, so P-loss from here will become now your velocity 2 squared velocity 3, sorry. So this is velocity 3 squared divided by your 2 times the density of air. So that is equal to how much? 0.8. Okay. So this become na your geometric factor. So multiply that one, you get the P-loss ng system.